we have two speakers. One is Darpan Dinkar, who is our VP of AI/ML and PaaS. And we have Yanqing Jia, who is the CEO and co-founder of Lepton AI. And they're together going to cover not just about the GPU portfolio that we announced today, but they're also going to talk about how you can derive the best possible performance and resilience with your GPU infrastructure on DigitalOcean. With that, let me just invite Darpan onto the stage. Take it away, Darpan.
Thank you. So we are in Texas, so I'm going to start with howdy to you all. And thank you for watching online. So today, next I'll be sharing a few things about our GPU infrastructure and the service. But I'll begin first with sharing some extraordinary stories about what our customers have done using our GPU service. Secondly, I will share something about the services where you can access as a developer, as a builder, the GPUs directly and leverage the infrastructure that we provide to you. Next, I will, of course, show all the ecosystem that exists in DigitalOcean. So when you're coming to our platform to use a GPU, you want to build applications where you're not just using GPU, you're using an application for various things, and GPU may be a part of it. So how do you use the entire ecosystem? I'll go through that, and also contrast and compare the options that you have for GPUs on DigitalOcean. And I'll share our roadmap for the next 2 quarters of what we are building for you, and we are excited to announce. As Pranav shared, we have a customer highlight where Yanqing is going to join us from Lepton AI. Lepton AI has been a very early customer of our GPU service. So really, really excited and happy to have him and talk about how Lepton has used our AI platform and created a service for their customers. So with that, let's go look into what's going on in the AI world. See, AI is evolving at a very, very rapid pace in terms of customer adoption, in terms of what's going on with all the models that so many companies are creating and adopting, and third, also the hardware technology. See, our customers are coming to us, and whether they are AI first, which means AI is how they do business, or they are looking to leverage AI to improve their business. It's part of their workflow. It is something that they're looking at to give a greater experience to their customers. We are seeing increasingly our customers move from experimental phase, POCs, and so on, to putting AI in mainstream adoption. And due to this, not only are we launching so many hardware services, but as Pranav shared with you earlier, a platform and a SaaS layer on which customers can build their AI. Secondly, if you look at the software advancements, whether it is open source models, you'll see later from Hugging Face, or closed source models that you all know of, there's just huge advancements in technology. And with every release, just a few months, we are seeing huge advancements in the pace of how these models are working, in the complexity of the tasks, and also in increasing number of use cases that every release comes up with. And now these models can be expanded to more industries and more use cases. And that is a wonderful trend for all of us, because it allows us to leverage what a few of us developers have done and be able to bring it to our business. And of course, how can we forget the meteoric rise of GPUs and the technology in GPUs? Leading vendors like NVIDIA, AMD, and others are coming up every few months with the next GPU. They're faster, better, they process more, and they're increasingly doing so many complex tasks that we could only imagine a few months ago. Now, what does that mean for DigitalOcean? At DigitalOcean, we are bringing you a platform. We are bringing you services where we can leverage all these models. We can leverage these hardware choices that are available to you, bring them into DigitalOcean, and all our services which help you create your end-to-end applications and allow you to run fast and go innovate for yourself and your customers. So we'll talk about that a little bit. Now, overall, in the keynote, you saw Bratin talk about our three pillars, which are simplicity, scalability, and approachability. So what are we doing about that? Now, whether you are looking at a very simple app or you're looking at a very complex app, we want to give you GPU infrastructure for all your needs. And we want to make it super simple to use. So if you're an AI expert or you're just starting out, we have a solution for you. Secondly, whether you're in your journey where you're just starting out, you have a quick app, you're prototyping, or you're just about to launch, or you've launched and it's seeing significant success with your AI app, we are in every part of your journey to help you scale from 0 to 100. And third, in making it approachable, we are constantly listening at what your needs are. So whether your needs are for very high performance, distributed computing at huge cluster level, or you're looking at just getting up and started, and you want to come in and see something that you can leverage in a matter of minutes, and it's very user-friendly, we are there for you. We are making it approachable. And next, think about like the cost advantages. Bratin shared what options we have in terms of budget you have. So whether it's sub-dollar all the way to $1, $2, or $3 for CPU or GPU hour, we'll give you a wide range of infrastructure from GPUs to help you create and look at the apps that you want to create on your platforms. Now, in my role, one of the favorite things that I love about being at DigitalOcean is when I talk with customers, when I hear their stories. And this is the favorite part of my job. There are fantastic ways in our customer ecosystem where our customers have created real applications, which, like I have chosen to share with you some 3 of them. And these are very purpose-driven, and they are very close to me. But they have found creative ways to tap into our GPU infrastructure and solve real-world problems. So I will go through a few examples. Our first customer is revolutionizing the music industry. Specifically, they have tools that they are building for DJs and musicians. Now, why did I talk about this? I love music, and I have playlists for almost everything. I have a playlist when I'm driving in my car. I have a playlist for when I'm really busy coding or writing a deep document at midnight. And also when I'm exercising, like you would see those fast-paced DJ mixed music. And this particular customer is targeting that market where DJs and musicians are creating music. Now, what I learned, interestingly, is when you are mixing songs, it is a science and it also is an art. For DJs who have been doing it for years, are expert at this, it's second nature as to how to mix these songs together. But for the rest of us, or for budding musicians, it's a very hard task. So some of those folks use very expensive software, which kind of allows you to do the mixing. Now, this particular customer has looked at the problem. The biggest problem with mixing 2 songs or 2 or more is the beats per minute. So you don't want a fast-paced music to be mixed with a slow-paced music, and you want them just to be right. Secondly, the key in a song, you want that to match as well. So they have seen that average listeners can notice transitions which are not done well. Or if not done well, they can actually be jarring. So this particular customer leveraged GPU-powered infrastructure to empower musicians. They build tools that mix, produce, experiment with sounds and visions and visuals, and leverage our AI infrastructure. And they have a service that is very affordable and can be used by an average musician. Now, if you were to use it, it's a cool app, and this was the reason I really thought I should bring it up. It's such a cool application of AI. Next example is of a customer who's tackling growing issues in online toxicity. So what I mean by that? Now, in platforms that you all are building, they may be dating app, they may be a gaming app, it might be a marketplace, it could be a social media platform. All of us are increasingly creating a lot of content, and we are increasingly social online. There's tons of user-generated content. And the issue is, every time you generate some content, we need to figure out if it's the right content for others to consume. It might include things like hate speech, it might have something about harmful behavior, or it might actually be something that somebody gets harassed with. So we don't want that content to live out there. Now, personally, I have 2 teenagers at home, and I just wonder what they are doing when they are on their phones and their laptops. And this is a constant worry to me. Now, this customer has used GPU-powered ML models and natural language processing on our infrastructure and created automated toxic chat detection and content moderation. Now, what this does is it creates a safer, scalable solution, and it's producing inclusive content for them. Well, with this, I hope not only everybody adopts this platform, but these kind of solutions for me to feel safer when my kids are online. And that's why I chose to bring you this example. In my third example, I will share a customer who's addressing challenges on the limited access to advanced medical image processing and the technology that researchers use. Now, we know lately AI has already been successful in detecting diseases early based on medical imaging. And I'm fascinated that over hundreds of years, we as humans have learned to share our knowledge. Researchers and the academic community have worked really hard over the years. They investigate, they test, they learn, and then they publish their work. And where these folks stop, the next set of folks can pick up this research and move the ball forward. And this process and this cycle allows advancements to move very, very fast. Now, this is what I love about this customer. They looked at this problem. See, average researchers cannot access these platforms. These are not affordable where you're doing ML training, and it's very hard for them to look at these specialized techniques and machine learning skills in order to tweak or learn or evolve these tools. Now, this customer created an open research platform. In doing so, anybody can now access their cutting-edge models, and they made it affordable and user-friendly for most of the people to use. They used our GPU-powered ML pipelines that accelerate health breakthroughs. Now, with these 3 examples, I have shared my passion for music and how we can bring joy into our lives with AI. Secondly, making our online spaces more safe. And third, literally, to enrich our lives and make things better for the world. With that inspiration, let me turn over to talking about our products. DigitalOcean has been empowering builders like you for a decade. Our AI-first infrastructure today caters to your needs. Whether you want to build very, very high performance models for advanced use cases, or you just want to get up and running and try it out or do some prototyping, we have you covered. So the first service that I will cover today is our bare metal GPU service. Now, why would you use a bare metal GPU service? Now, if you are somebody who wants to eke out every little power, every bit of performance out of the GPUs, you would want to go use this. With this service, you will get 8x or 8 NVIDIA H100 cards in a host. Now, you can use this as a standalone, or you could cluster them together. These are single tenant. There's no virtualization, which means that there is no noisy neighbor, and these are very, very high performance. Of course, each one of them comes with a fast local NVMe storage. Some of our customers have used this to create a clustered file system. And you have direct access to hardware. Now, the way the billing works is you use a contract-based billing. So you can come to DigitalOcean and say, hey, I need 32 of these hosts, and I want that for 6 months. And so what our team will do is give you the lowest price and make it really, really affordable to you. Now, what this means is you'll have to set up your own orchestration because they are bare metal. And these are highly customizable. You can customize your environment and customize the security you want. Now, just because you have to do all of this doesn't mean we'll let you be alone in all of this. We love our customers. And so we also provide high-touch engineering support for complex deployments. So if you're stuck, you just reach out to us, whether through our tools or through Slack, and we'll be there to help you. Our second service that we provide to you to directly access GPUs is something that I'm really, really proud of. I call it the versatile Swiss Army knife. Our goal with this service is to make everything simple. So we do a lot of heavy lifting for you. This is GPU Droplet. It's a very simple, scalable, and on-demand virtualized GPU that you can use. You, as a developer, can come in and just create a droplet. You have access to a GPU. If you want just one GPU, you can use it, test it, put your prototype in there, and when you're happy, you can shut it down, store the results that you have, and go to an 8x. Or, not just standalone, you could cluster these together and have a bigger workload. So these scale up and down, and in terms of billing, you only pay for what you use. So you can get started, use the GPU, store your results, and shut the machine down. So if it takes you 4 hours to do it, you only pay for 4 hours. And this is why, depending on your use case, this is very on-demand and easy to use. We already pre-install AI ML aware and ready software and drivers for you, so you don't have to go do it. And the most important thing here is it plays very nicely with our integrated system. So if you want to go to a database, if you want to store your results in spaces or volumes, or if you want to take a backup, all of these are nicely integrated into the system. This could also be a solution where if you have a longer or a bigger end-to-end app where GPU is just a small part of it, you can leverage this and use our ecosystem. So for all of you, what I also did was to make it simple, I did a comparison chart. So this helps you understand when do you use one versus the other. Now, of course, both options are great. Both options have greater than 99.5% uptime SLO. Both come with local NVMe high-performance storage. And of course, both can be standalone or clustered. Now, here's a way to look at the use cases. As I mentioned, GPU droplets are easy to use. If you have async workloads where you want to use GPU only for a period in time in a day or a day in a week, this is the best thing for you to go use. Secondly, if you're running a POC, just need one GPU. You do not need the entire 8x GPU server. This is the best thing for you. This is also a great thing if you are running long-term, small to medium scale inference as an example, where you do not want to get into the complexities and managing the entire infrastructure. Again, as I mentioned, these are on demand and you can scale things up or down. On the side of bare metal, you are going to look at some things which are very, very powerful. You can configure them the way you want. So some of the workloads that you can run are like some fine-tuning of a large language model. You can do distributed training. You can run some very complex threat detection, for your network. Or you can orchestrate multiple workloads. If you and your team have a lot of mixed workloads for AI, you can actually leverage a pool of servers that you can reserve for a longer time and get a lot of cost efficiency. So if you're online, feel free to just take a look at this and see which one makes sense to you. Hopefully this helps you to choose the best solution for your needs. All right, so we talked about Droplet and why I'm really excited about them. See, as a developer, sometimes you don't just need a GPU, you need an entire ecosystem. So with this GPU Droplet, you can go and store your data both in structured and unstructured fashion. You can use our volumes product, you can use our object storage, you can use NFS to store all that data, or if you have some cached results that you want to share with your users at a very high rate, you can use Redis. You could also use structured data, read and write out of our managed databases. Now, many AI applications use vector databases, so you have options of Postgres PG Vector, which is available to you, as well as OpenSearch. Later on, we'll hear also about Hugging Face. So Hugging Face implementation in DigitalOcean is created on top of Droplet. It is an easy way where you can get up and running in minutes. And of course, last but not the least, you can master Jupyter Notebook setup and get started with the latest Llama models using tutorials. So there are a bunch of tutorials. We provide all of these things so that you allow us to serve you whichever journey you are on. And with our infrastructure, we handle the complexity so you can focus on building the killer app. With this, I want to talk about what our roadmap looks like. In some ways, we're really just getting started. In the last 6 months, last year, second half of last year, we launched GPU Droplet based on NVIDIA H100 processors. We also provided a bare metal version of it. Now, if you see what's coming down the pike, we're bringing NVIDIA H200, which is expected to have twice the performance for some inference workloads. And it's one of the fastest GPUs out there that you can get your hands on. This is coming in a matter of weeks, and we're announcing it soon. Secondly, for some customers who have a variety of use case and want to see different price points based on their use case, we are coming up with GPU Droplet versions, and we are bringing you access to NVIDIA A4000, A6000, and L40S. And again, if you were listening to Bratin and in our keynote, these come at variety of price points. Also, I'm happy to announce, very excited about MI300X from AMD that we are going to announce and bring to you in a matter of months. So as our data center team is accelerating the pace at which we build out these servers and GPUs and bring them to you, I can't wait for all of you to look at the options available to you and build the next app based on the use cases you have. So with that, from this exciting news to the next, I want to welcome Yanqing. Please come to the stage.
Thanks so much. It's great to be here. I think I want to basically start by first talking about why suddenly we care about cloud. Isn't that a topic that's already 20 years old, things like that? I think the idea is that we are actually seeing a third trend in the cloud evolutions. In the old days, basically when 20 years ago when we started with web cloud, all the idea is basically about moving data around, right? Web pages, content, and stuff like that, moving it from the server to your hands. And then with Web 2.0, the trend of data cloud is basically focusing on actually doing recommendation systems so that we match you, the reader, and the content over there, which is also very data-centric, and in some way, basically like Databricks and Snowflake started basically building a data cloud. And all those basically are having very strong data as the gravitational factor. Now, when AI came and when ChatGPT came out, what we are actually observing is that the data manipulation or data transform is actually quite small, and you're actually spending quite a lot of time on actually doing the compute. Imagine a ChatGPT session where you ask ChatGPT a few questions, that's like a few kilobytes of size, and it does a lot of compute. And it gives you back a little bit of answer, which is a few kilobytes, but it's computed with a massive amount of GPUs and things and massive amount of modules back there, right? So AI compute right now starts exhibiting itself as more compute-centric, kind of similar to the old school scientific computation or an HPC kind of fashion, and with the manifestation of just a bunch of GPUs, or we funnily call it JBogs. Now, the problem with JBogs is that a lot of the AI native companies or startup CEOs are actually having these kind of tricky problems, which is literally what we heard in the market. As a CEO or a CTO or a CIO, you want your team to be productive and not really spending a lot of time basically like just dealing with GPUs. You want your developers to be able to efficiently train, develop, and deploy models. You want your infrastructure to be efficient so that your GPUs, which are really expensive, are actually able to be utilized at a high fashion, right? At a high utilization fashion. Now, looking at the market, there aren't really good solutions. You have two options normally. One is the good old Slurm, which is like decades old, and it's very, very simple, elegant. It's very nice to researchers, but the problem is that Slurm is not really flexible. It doesn't really allow you to install new software. It doesn't really have multi-team collaborations and things like that. It's just not built for the internet age. The other option that we often heard about is Kubernetes. Now, it started being very beautiful because Kubernetes and cloud native and things like that. And very quickly, what you realize is that Kubernetes is actually designed for SREs, for site reliability engineers, and not really for AI developers who have ideas about, like an LLM, a training session, a bunch of machines, and not really the Kubernetes jargons, as I learned, like pods, ingress, parallelism, completion, and my head is already exploding. Right. So we want some sort of solutions that are actually really AI native. And me and my co-founders, we are basically a bunch of folks who started writing, open source libraries like Caffe, PyTorch, and things like that, in big companies, train models and things. And we're like, hey, let's build a platform that's really tailored towards AI engineers and AI research scientists. So Lepton's clients today, for example, involves robotics companies or basically foundational model training companies and also kind of like Gen AI, image generation and video generation companies, where the folks are basically saying, hey, I want to train a model with a bunch of GPUs, and please deal with all those kind of detailed, detailed orchestrations, management, health, and things like for you guys. And we're also kind of like serving, interestingly, a bunch of enterprises. And there's one finance institute who's basically using GPUs to develop their quant trading kind of strategies with a bunch of GPUs, so that and in their case, they need really high like security, confidentiality, quality control, and stuff like that, which are all enterprise ready, right? Now, we started basically in 2 years ago. We're basically talking together with DigitalOcean, and we're pretty happy about building our platform on top of the DigitalOcean infrastructure. And I want to basically show you a bit about what kind of a daily engineer's life will look like. One is today there's quite a lot of models that are being deployed, LLM models to be more specific, right? So on the platform, you don't really have to deal with all those kind of like the orchestration and things like that. You just start launching the LLM service, give it a name, and then we naturally integrated with all those Hugging Face models, a lot of great models on Hugging Face, such as Llama and things like that. You pick a GPU, and then you basically say, well, I want to do auto-scaling and things like that. And with one click, it basically gives you a model. Under the hood, what we are basically using is our proprietary model, a runtime engine that involves all those optimizations, such as dynamic batching, speculative decoding, quantizations, prompt caching, and all those things you have heard about. And we basically baked it into one single deployment that you can pull up in under 30 seconds, and performance is pretty good. If you want to do some benchmarks and things like that, this guy runs on a single H100. I think it's a Llama 8V model, something like that, and resolution is not the greatest, but you can see that it runs, at something like 300 or if 2 cards with 600 tokens per second, which is very good for interactive sessions or basically other kind of LLM use cases. 8 billion models are really popular these days, and we see a lot of adoptions. Lots of folks basically run on platform with hundreds of billions tokens per day or something like that. Now, after the deployment, well, basically after people start running their applications, and things like that, there's quite a lot of need on actually fine-tuning a model. And training becomes a relatively more sophisticated problem because, if you use Slurm and things like that, normally basically there's a bunch of machines, and machines go down quite often through no one's fault. It's just GPUs, right? And basically we provide a platform where we pull up a bunch of GPUs, set up an environment with Nickel or Rocky and things like that, and then basically we run torch distributed or whatever kind of jobs you have, and we basically manage this whole thing end to end. Sometimes the GPU goes down, and then we automatically detect that, finds another GPU from the fleet, joins the group, and then it continues training. Sometimes the training jobs are not really kind of fault tolerant, you have to restart the whole job, and then we give you a really high performance storage on top, in addition to the GPUs, so that you can just directly load from the latest checkpoint, and within a minute or so's time, you can just like very happily continue to train and things like that. We've been basically running a couple thousand GPUs today, and in total, and then basically like what we've been observing is very similar to what the meta paper about Llama 3 talks about. Every month, every week or so, there is a couple GPUs going down, and you have to basically make sure that on the application level, or basically on the development level, things are actually staying really stable without having to be disrupted by the just GPU failures by nature. Right. Under the hood, so basically what we were basically running is a software library called GPUD. It basically proactively detects all those kind of crazy errors that GPUs might exhibit. Basically, this is the interface. We have, like say, a bunch of machines listed. This is one of our production clusters. Each machine basically runs GPUD as a daemon inside there, and it proactively checks the common issues that GPUs might have. For example, it's like XID errors, infinite band fabrics, and then ECC errors and things like that. It also proactively checks whether the Linux system itself, whether we ran out of FIDs, whether the disks are full and things like that, so that you can make sure that all those machines under there running your training deployment jobs are as healthy as possible. GPUD is a standalone API, well, a standalone library that you can actually download on your GPU boxes as well. And we use that to basically, set up the Lepton platform. As you can see, the platform has, all those local 0-point-something IP addresses. That's because we provide a globally virtual network to connect all your resources and then make sure that they are happily talking to each other and not going down anytime. So basically, with that, let me share some numbers with about the quality. We've been working together with DigitalOcean for about a year's time, a little bit longer than a year, and then we've been working together to basically ensure that whatever kind of GPU issues down there are basically being very nicely detected and addressed by the two teams working together. We are basically seeing a machine level 99.5%. SO, and if you think about, the deployments and things like that, because we have a platform, any kind of issues down there with the GPUs can be actually covered by automatic recoveries, redundancies, and things like that. And we can actually, in practice, reach something like 3 nines or 4 nines for deployments and things like that. Imagine if there's an LM deployment going on, serving a lot of traffic, and one of the GPUs is getting a little bit flaky. We can basically find you the GPU next to it, or the GPU next rack, or even the GPU next data center in case there's a power outage. And then within a minute's time, or basically hopefully seconds time, your service is basically back to normal. We are really excited, basically share a few updates about the product side. So right now, available right now, basically enterprise customers on DigitalOcean can actually bring your own accounts to the Lepton platform. So all your computation resources or your contracts with DigitalOcean, things like that, will be happily basically honored, and we will basically do the machine orchestration and platform and fast inferences for you. And with the availability of the newer GPUs and things like that, I think we'll be natively supporting all those. And one thing that we are super excited about is that the Lepton LLM engine actually naturally supports the MI300 GPUs as well. We think it's very important, mainly because today there are, if you think about the market right now, people care a lot about like 7dB models or even larger, like 600B DeepSeek models. And it used to be a little bit difficult to run on other GPUs that might have a memory constraint. So with MI300 and other larger memory kind of GPUs, you can basically run a 7B model in one GPU, or run a really large DeepSeek model in one box, and that makes your life much easier and more cost-effective and things like that. So we are, we're looking at a really exciting. Looking back, we're actually seeing a very exciting year of collaborations, and we're looking forward to a very productive 2025 as well. Thanks.